So in this chapter, we will be discussing about units and measurements. Now, when you define unit, it is something that has been created arbitrarily. That is, we have all the people in the world have agreed to a common notion as to what should be a particular unit. That is, for a physical quantity, what should be its unit. So that we know is this is what is man-made. This is man-made. It is not a discovery, but it's an invention. So if you are asked the question what is a unit, the way you can define it is that it is a measure of a physical quantity which was decided and agreed upon. This is and agreed upon by majority, and also which was chosen arbitrarily. Now you have to keep in mind that these are chosen arbitrarily and they are accepted internationally. These are accepted internationally, and this standard reference point and this standard reference point is known as your unit. So basically, if I go through this statement summarizes my whole of units. So what is actually unit? Now, there are certain units which we can physically see. Say suppose this is a rod. It has a length L. So length is a physical unit. There are other certain things which we can feel, like time. So time is a basic fundamental unit and it cannot be derived from any other unit. So time is also a fundamental unit. So now there are two types of unit. One are fundamental or base units. Fundamental or base units. All those units which cannot be derived and is the basic of a particular quantity, that is a base of a particular quantity, that type of quantities or that type of units are known as fundamental units. Say for example, you have length. Area can be derived from length. So the basic unit of length L can be meter, centimeter, but beyond this we cannot have further differentiation of length. So length is a basic fundamental unit. Now after fundamental unit you have a derived units. So what are derived units? Derived units are basically the units which can be derived from your fundamental or base unit. These are fundamental units, these are derived units. Say for example, let's say force. We know, we have some idea equals to force equals to mass into acceleration. So mass is a fundamental unit. Why? Because we cannot derive any further quantities, that is a quantity that is can be derived to get mass. There is no such possible quantity. So mass is a fundamental quantity. Now force is equal to mass into acceleration. Now what is acceleration? Acceleration is dv by dt, that is dv by dt, that is derivative of velocity with respect to time. Now what is velocity? Velocity is length upon time, that is time t, length upon time t upon time t, that is twice t to the power 2, that is length divided by t to the power 2. So now the unit of force, if I write unit of force F equals to, it will be mass into L to the power minus 2. So m into L to the power minus 2, this is what we know as force, and the unit of force is Newton. So Newton is a quantity which can be derived. So this is the example of a fundamental unit and a base unit. Now after you have discussed what's are units, now let's talk about measurements. Now we know what are units, but what about measurements? So say suppose you are saying 1 meter. So what is this 1 meter? The quantity meter, the measurement meter. What is this related to, and who decides all the measurements? So if we ask ourselves this question, who, then we come to the International System of Units. So here, let's have a look at our International System of Units. So the establishment of International System of Units, before this, people from different countries were using different measurements. So then there was a need to establish International System of Units so that when a scientific discovery is being made, it can be shared and utilized equally. So therefore, the need for International System of Units was created. Now earlier, some of the units that were used were CGS. Now CGS means the base units, that is the fundamental unit of length was centimeter. That of mass was grams, and that of time was seconds. Now there were certain other units like FPS, where length was measured in foot, mass was measured in pounds, and time was measured in seconds. And MKS, so length was measured in meters, mass was measured in kilogram, and time was measured in seconds. So after that, the International System of Units was established and it was abbreviated. This was abbreviated as S.I. Like we say, what is the measure of the quantity in SI units? So this is the measure of the quantity in SI units. So they use standard symbols. So for length, SI unit for length was meters. That for mass was kilogram, that is kg. For time, it was seconds. For electric current, it was ampere. This is A. It was denoted by the symbol A, ampere. So if we go, that is for thermodynamic temperature, thermodynamic temperature, it was given as Kelvin K. For amount of substance, it was given as mole. How many moles of, like in chemistry as you have come across, how many moles of a substance are there? So this is given as mole. For luminous intensity, it is denoted by candela, or the short form is CD, candela. Now, the next question that we come to is, what is this length meter? What is 1 meter? We should have a standard measuring, we should have a standard measure as to what 1 meter accounts to. What does it accounts to? What is its physical value? Because before it was established, now we know that this particular length is your 1 meter, say suppose. But before it was established, some people might call this small length to be 1 meter. Some might define this length to be 1 meter. So we should have a standard 1 meter measurement in our physical world to define what is 1 meter. So let's have a look as to how all the units of SI system has their particular origin.